Okay, horizontally launched projectiles. So we've been learning kinematics both vertically and horizontally. Okay, so when we calculate what's happening on the x-axis, what we must realize is it has almost little to nothing to do with what's going on the y-axis. Okay, so when an object, a projectile, when a projectile is launched horizontally, okay, there is nothing but the momentum of the object carrying it in the horizontal direction. Now, in the vertical direction, we have the force of gravity, the the attraction of the Earth, the gravitational acceleration of negative 9.8 meters per second squared. So as soon as we leave this edge here, gravity begins to accelerate us downward at this accelerated rate. Now, as long as we're on this building, the normal force of us standing on this building and the building holding us up is going to keep us from accelerating in free fall. Now, here's how we calculate in this particular instance how much velocity our student will need. Let's say he's a parkour person who likes to jump on buildings for some reason. I don't know why, but anyway, let's say that's the case. Okay, now your drop is from here to here. That's your delta y. Now, let's make that something conservative. Delta y equals 1.5 meters. Easy, okay? Now, your horizontal range, or your delta x, let's make that something that, you know, somebody who would have trained might be able to do. Let's say 3.0 meters. Now, the question is, to clear this jump, how far or how fast would our parkour person need to be running? How fast would they need to be running? So the first thing we need to do is calculate the time that they're going to be in air. So let's relate this back to our kinematics equations. So here we go. Delta y, delta t, v naught, v and a, but we can say g. Okay? Now, we know that the initial velocity on the y-axis is 0 meters per second. We can put a little y there for that. We know that this is negative 9.8 meters per second squared. Okay? We know that our drop is a negative 1.5 meters. Okay? And what we're looking for is the time in seconds. So what we're going to do is we're going to use an equation that does not involve final velocity. We're going to use delta y equals v naught t plus 1 half gt squared. Now, here we go. Since our V initial is 0, we can cancel that expression. So delta y equals 1/2 g t squared. Now, through the magic of algebra, we derive this equation to say t equals the square root of 2 times delta y over g. Now t equals the square root of 2 times negative 1.5 meters over negative 9.8 meters per second squared. So how much time will this person be falling? Let's see. Square root, parentheses, 2 times negative 1.5, close parentheses, divided by negative 9.8. That gives us a time of 0.55 seconds. So our time is 0.55 seconds. That is approximately how long that they'll be in the air. So how fast will they have to run? Now, in order to calculate velocity, I'm going to change the color here. The velocity, horizontal velocity or velocity period, but the horizontal velocity will equal the delta x, or the range, divided by the change in time. So our delta x is 3 meters. And our change in time is 0.55 seconds. So 3 divided by 0.55 will give us a horizontal velocity of 5.45 meters per second. So if that person is running at least 5.45 meters per second, then they will be able to clear this jump with a trajectory that should look something like that. Okay, 5.45 meters per second. All right.